curves help us determine the thickness of foam to use and the proper density of foam to use. They help us to understand what G's we would expect to see from different drop heights. It also helps us to understand what G's we'll see under various loading situations. Altogether, they give us the proper determination of foam cushioning density as well as thickness of the foam. Each different type of cushioning material should have its own cushion curve. So whether it's a 1.2 polyethylene or a 2.2 polyethylene, they're going to have cushion curves associated with that particular product. And that's going to help you determine how many G's that particular material sees from a specific drop height. So you may have to run through a couple of different cushion curves to get the exact loading and G levels you're looking at from a particular drop height. So cushion curves wouldn't do you any good if they were only from one specific drop height and you only did it once. Foam degrades over time, tears in the corners, so you always want to have at least 4 or 5 drops that you have good data from to understand what's going to happen over time when you ship something. Cushion curves should also be done from a variety of drop heights. Depending on what the circumstances are, how heavy your product it is, whether you're planning on being forklift pallet jack only, whether you expect handling of this product. So that's why you have different drop heights as well as multiple drop impacts to determine what G level your product is going to see from a specific drop height, even though that drop height may be encountered multiple times throughout its journey. Each cushion curve is going to give you a lot of information. The first bit it's going to give you is what the drop height was. It's also going to tell you what the sequence of drops was, whether it was drop 1 through 5, be it. It will also tell you, based on the loading of 1 square inch of material, how many G's you will see upon impact from this specific drop height. So this specific drop height is 30 inches. Now, let's take, for instance, this particular graph shows you different thicknesses of foam and what their performance was. So if you have a 1-inch material thickness of foam and you load that on this particular chart at, let's say, 0.2 pounds per square inch, you would expect to see 100 G's on a 30-inch drop. So you can also tell that if you take this material up to 4 inches thick, you can load it all the way out to 1.2 pounds per square inch and get yourself all the way down to about 28 or 30 G's. So depending on the fragility of your unit, you can determine, even from this one particular cushion curve, what material would be the most appropriate to use for the conditions you anticipate. In this example, we'll look at a 500-pound unit with a 35 G max, meaning it'll break in these 30 seconds. We're going to put this on a 60 by 25 inch footprint of a floater, but we're not going to make it full foam underneath. We're going to slice it up into strips, as you can see here. So our actual load area will be about 20 by 25, and we'll have about 500 square inches of foam. So that 500 square inches of foam needs to support a 500-pound unit. So we're going to load that foam at 1 pound per square inch. So if we look over at our cushion curves on the side here, we'll see to get down to 35 G's, 2 inch isn't going to do it. If I take 2 inch and load it at 1 pound, I'm going to be up to 55 G's on that drop height. If I take 3-inch foam, which is the light blue line here, and load it at 1 pound, you'll see that we see 35 G's on impact. So that's what we would expect to see. This particular cushion curve shows a 30-inch drop height, so we know we would be safe. If it was a 12-inch drop height, we would actually see less G's with the same type of load. So there's your example. We would use this as a particular 2.2 pound polyethylene cushion curve. And if we use 3-inch material at a 20 by 25 loading area on a 60 by 25 footprint, a 500-pound unit would see 35 G's on a 30-inch drop. So there you have it. Feel free to leave any comments or questions, and thank you for watching.